Hello, everyone. Welcome to our webinar today. Commonwealth Associates present Understanding ASME B31.1 Considerations for Pipe Support Inspection and Flow Accelerated Corrosion. I'm going to wait a few moments as people start and continue to trickle in. Thank you all for being here today. I'm here with Kristi and Kenya, our wonderful presenters. You feeling good? You feeling ready? Okay.
Got this.
Good. We do have this. I'm very confident in today's proceedings. All right, without further ado, it is 12 o'clock noon time, and so we will get this show on the road. Again, thank you everyone for coming today. Let's hop to it. All right, Kenya, next slide, please. So first off, my name is Del Belter. I'm the marketing manager at Commonwealth Associates, and I have my email here if you'd like to get in touch or have any questions concerning today's webinar event. But before we get started with the meat of what's going on today, I want to take you through a couple kind of housekeeping items. First off, yes, you were in the right place. This is Understanding ASME B31.1. Yes, it is also eligible for a PDH credit. The way you would redeem that is after this webinar, you will get an email from GoToWebinar from this session with a certificate and a note saying like, hey, or should be saying, hey, this is valid for a PDH credit hour. If not, the certificate itself should be okay. If you have any other questions, you can, again, let me know, but you should be in the clear with the redemption of the certificate that comes from to you after this webinar. The next thing is that we'd like you to all be engaged. We'd like to make this a conversation, not just a talking at you situation. So we have some webinar tips on if you've never been to GoToWebinar before, the interface can be a little different than Teams or Zoom. So I'd like to show you some tips on how you can engage with myself and our presenters today. First off, we have audio preferences. So if you want to use your phone or go for a walk while you're listening, or change your speaker setup to something nice surround sound, that might be fun. You can change your audio right in, let's see here, right in that little first arrow pointing to audio preferences. If you do have a question, we do have a session for question and answers at the end of the presentation. If you have a question, you can go click on this little questions box, and that will allow you to input a question, and we will ask those questions at Q&A time. Also, there's things like you can raise your hand if you have something that you'd like to say, like while they're speaking, and you can address an immediate question if need be. We do have a handout for today. If you are interested, today's presentation is available as a downloadable PDF in the handouts section. It should say 1 of 5 now, but it's been updated. But you can download today's handout there, and you will get the complete deck, slide deck from today's presentation. And then there's the group chat. So if you would like to, kind of comment or cheer on, or agree, or have a comment or something about what's being talked about in the presentation today, or you're interested in messaging myself or the presenters with any other feedback, if you have technical difficulties, you can reach me there as well. So next slide, and I mentioned this earlier, the Q&A session is coming in at the end. So put in your questions and we'll address as many as we can in the time that we have allowed. We're only going to about 1 o'clock today, Eastern Standard Time. And any questions that maybe aren't answered or left unanswered, we will be more than happy to reach out to you via email to get your question answered. All right, next slide. So a little bit about Commonwealth before we get started. Our purpose and our passion is to provide expert engineering and consulting services that enable a more reliable and resilient power system. That's really why we're here. And we do that in a bunch of really cool ways. Kenya, next slide. So a little bit more about Commonwealth. I think it's now 50 states. Is that right, Kristi, that we're working in Alaska now, or so around the 45 number? more than 2. That's a lot. So we have that. We've got 8 offices across the country: Spokane, Tulsa, Orlando, Cleveland, Atlanta, Charleston, and Jackson, Michigan, or no, Charlotte, not Charleston, Charlotte, North Carolina, to serve our clients in their communities as best as we can. Been doing this for a long time, and we are 100% employee owned. So it's a really great company that has a lot of really wonderful components, and I'm excited to share just a small part of one of those components with you today. Next slide. Again, our main capabilities are in substations, power generation and energy, transmission and distribution, renewable services, land and right-of-way, and electrical systems studies and planning services. So if any of these capabilities are what you are looking for outside of today's subject matter, please give me a call and we'll get you the resources that you need to get your project done right. Next slide, please. Power generation and energy director, Kristi Vilminot. She's one of our presenters today. A lot of great stuff, everything from combined cycle, CHP stuff to process piping systems. Whoa, cool, huh? Balance of plant systems, electrical system distribution, site planning, civil structure. We keep busy. We've got some good people here to hear from that are definitely experts in what they're going to be talking about. So, next slide. Now, before we introduce our wonderful speakers, I'm going to do a quick poll just to get the temperature of the room of what do you all know about this topic? How familiar are you with pipe inspections and flow accelerated corrosions? I know that I would definitely fall in the somewhat familiar side of things, but we want to know where you fall in your familiarity. So I'm going to launch a poll here in just a moment. And we'll take maybe about a minute, click your answer, and we'll see where everybody lands. Here we go. How familiar are you with pipe inspections and flow accelerated corrosion? So we got about 10 seconds has passed, so we'll take a few more moments in order to get everybody's votes in. About 5 more seconds. All right, thank you everyone who participated. With about 76% of our vote, we are going to see our results. We've got about 64% is number one, with somewhat familiar. They're aware, not necessarily involved. 32% of our audience is not familiar, no experience, no knowledge of either topic. 5% say they're very, very familiar, involved as a pipe inspector, and with 0% saying that they're involved as an operating company. So we have a good crowd. This is going to be a great presentation for this audience, and I'm looking forward to hearing from Kenya and Kristi. All right, so Kenya, oh, sorry about that. We got coming right up to pull up the presentation here on the introduction slide, and then we will. Okay, there we are. Take it away. So yes, Kenny McKinnon. Hello. Could you do a quick introduction? Tell us, even just what's on the screen. Just say hello to the group here.
Sure. Hi. My name is Kenya McKinnon, and I am a mechanical engineer, oftentimes a project manager in our power generation department here at Commonwealth. I have 18 years of experience, mostly in CHP and combined cycle gas plants.
Thank you, Kenya. And Kristi.
And I'm Kristi Vilminot. I'm the Director of Engineering for our Power Generation and Energy Group, as well as our Electrical System Studies Group. I am a mechanical engineer by degree. I have a little bit over 33 years of experience in the industry, ranging from small plant betterment projects up to large combined cycle and coal design projects. I also am the chairman currently of ASME B31.1 Code Committee, as well as the Vice Chair of ASME B31 Standards Committee.
Thank you. I'm looking forward for you to sharing your knowledge about this committee and pipe inspection in general. So with all that said, I think we're ready to go. So I'm going to hop off my camera, save you all some bandwidth, and Kenya, take it away.
Okay. So I want to begin by going through our agenda here for the presentation. First, we're going to discuss why we do the pipe inspections. And then secondly, we'll look at what we're looking for during those pipe inspections. Thirdly, how often to repeat them. And then from there, Kristi's gonna come and talk about flow accelerated corrosion, what it is and why do we care. And then lastly, we'll talk about how do we know where to inspect for flow accelerated corrosion. Okay, so why we do pipe inspections. Pipe inspections are mandated in ASME B31.1 code, particularly in the Chapter 7 operation and maintenance portion. And this is, of course, because of safety primarily. Managing safe piping services begins with that initial project concept and design, but it doesn't end there. It's essential that operating companies maintain safe operation of the piping throughout the life of the plant. So therefore, pipe inspections are crucial. Also, identifying issues early extends the life of the critical piping systems. I wanted to note here that B31.1 does not state a detailed set of operating and maintenance procedures that covers all cases for all plants, but does provide some basic requirements for what they call here covered piping system. So it is up to the operating company to develop procedures for piping systems deemed necessary for safe operation of their facility. And therefore, there could be additional systems beyond these basic ones covered here in the code that would need to also be inspected. And Commonwealth is involved in helping clients to develop those procedures. So per B31.1, the covered pipe systems at a minimum should include 4-inch and larger of main steam, hot reheat steam, cold reheat steam, and boiler feed water piping systems. And it should also include other systems where the design temperature is greater than 750 degrees Fahrenheit or the design pressure is greater than 1025 psi. Okay. So what are we looking for? This picture here depicts an example of some of the problems we encounter during our inspections. As you can see, this spring can has experienced some corrosion on the bottom of the can. In this case, we would recommend this spring to be replaced to ensure that it is operating as intended. And then here we can get into other things we would be looking at. So furthermore, we would look at loose components. You can see here in that picture on the top left where this the support isn't connected to the piping, that would be something to note. But also the picture at the bottom where there is loose nuts off the turnbuckle there. So that would be something that we would be looking to identify. We would also review spring settings, both when the plant's in operation and when not in operation, so that the hot and cold positions are recorded. And then we take particular notice when springs are bottomed out or topped out, such as the picture there in the top right, where it's showing it's topped out because the arrow there is at the top of that spring scale, meaning the load on this support is less than design. The functionality of the support, that could be ensuring rigid bottom supports are resting on steel and not uplifted, and also ensuring rod supports appear to have tension in the rods. The migration of the piping, it's just making sure that there's no unexpected piping position changes, such as piping shoes sliding off steel or bent rods. And then lastly there, the vibration, sometimes that can be visibly seen. And then at other times, we've been able to touch the insulated piping with a gloved hand, and you can feel if there's excessive vibration in the piping. Okay, and then the frequency of the inspections. Per ASME B31 code, the frequency is up to the operating company, but it is not to exceed a 5-year interval. So some companies, some clients have chosen to do 3 or 4 years, but if for some reason the hot and cold walkdowns are not performed within 5 years, the justification must be documented. Okay, and with that, I will turn it over to Kristi to discuss flow accelerated corrosion and why we care about it.
All right, thank you. Before I get going, Del, do we have any questions that have came in yet on the pipe support inspections?
At this point, we do not. I know that you had made a comment. If you do have questions, we can address them in real time. So
Yep.
feel free to pop in your comments there and questions, and we'll get to them. Thank you.
Okay, thank you. So to get started on flow accelerated corrosion, this is more recent terminology, probably in the last 10, 15 years of my career, that it became more apparent and more common. We started having more problems with it. So we've included a definition here per ASME. So flow accelerated corrosion is the corrosion process that leads to the wall thinning of certain systems. So a general explanation of it is that these systems typically build up a certain amount of corrosion on the inside of the pipe. Flow accelerated corrosion tends to attack that barrier that's inside the pipe and allows the fluid then to attack the wall thickness at an expedient rate, which could cause through pipe failure. And because we're talking different high velocity of steam or water systems, it could be a safety concern. So the parameters that affect our metal loss include the temperature of either the water or the steam, some of the water properties as far as like the pH, the oxygen content, the quality of the steam, as well as the velocity and the actual layout of the piping and what piping material you have that you are using to hold the system in place. They've also added additional criteria as part of B31.1. So if you look at Table 5 in the non-mandatory appendix, it talks about the parameters. Some of them that I just mentioned, it actually gives the flow accelerated rate will increase as if these parameters are exceed or are lesser than these numbers listed here. So ASME now gives guidance on this. So your flow velocity, if you're over 10 feet per second for water or 150 for steam, those are, is one of the parameters that's going to lead to this. If your pH level is less than 9.2, oxygen less than 30 parts per billion, your temperature ranges for water or wet steam. So your critical steam systems don't see this issue as much as the ones that are in the wet steam area, and for steam qualities that are less than 100%. So they give some criteria here. The more parameters that you are checking off that you're falling in that area, the increased risk that your system will have. And some of the systems that typically fall into those categories are your feed water, your condensate, blowdown, if you have a turbine crossover system or an extraction steam, or any feed water heater, drains, or vents. So with this picture, we're going to show a little bit of like what kind of areas do you want to inspect in your plant. So based on the criteria that we just gave, a lot of what is impacted with flow accelerated corrosion is how your flow is impacted. So if you have a lot of flow modifying components, so you have elbows, you have T's, or if you have control valves where you then have some kind of gate that's impeding the flow of the system, different ways that impede flow and create turbulence are the areas that we have to look at. So I have this picture that's of the actual system, and then can you go to the next one? And then in here, some of these are what I just talked about, but this in the top corner is a PNID of that same system that I just showed physically. And when you look in this system, you can see, and you could see in the physical picture, that these components are really closely tied together. The two large valves that were in the middle of the control valve station are actual control valves with isolation valves on each side of it, as well as you have multiple T's, a couple drains. So you have a lot of physical components in this very tight area that is impacting the flow and causing extreme turbulence. So the areas of concern that are also called out in the non-mandatory appendix talk about these items, right? Elbows, T's, reducers, how much piping you have upstream and downstream of fittings that allows the flow to get laminate again, or where you have piping upstream and downstream of orifices. So where you have this was a system that we helped a client with because they were continuously replacing some of the components in the system due to the flow accelerated corrosion. They were replacing some of these every couple of years. So like some of these control valves were wearing out because the turbulence was so great, like downstream of it. So this is an example of, what we helped them do was create more space between fittings, make a more smoother transition. So you don't have, you have room in between fittings for the flow to go from turbulent to laminate to, so it's not spinning and creating vortex that's wearing out your piping. There is not criteria directly for methods of detection for flow accelerated corrosion. Some of the methods that can be used are visual, radiography, or ultrasonic. ultrasonic is the current industry practice. People typically would take ultrasonic thickness examinations, and they would do it in a grid pattern based on the recommended locations of where to take them. And they would identify different reference points for each of the grid intersections. And then if thinning is detected in any of those specific spots that they originally took the exams from, then they would refine the grid pattern to be a more tightly represented grid pattern, and then repeat it to try to make sure that, you know, in that smaller area, you found one spot that had thinning, but how far away from that spot that you originally detected does the thinning pan out? And then you also need to take that measurement that you have and make sure that that system still has the acceptable wall thickness per paragraph 104 for the minimum wall thickness for your design pressure conditions. And so if it doesn't, there might be a cause to reduce the design pressure, to downgrade your design pressure that you're using for your system prior to the time that you're able to replace that piping. Or if you are still within the wall thickness, then you would need to set up a program for how quickly you're going to repeat the detection to make sure that you're still staying within a safe wall thickness for the safety of your plant and those that are operating it.
All right, thank you, Kristi and Kenya, for your overview on that. We do have time for questions and answers, and still waiting on some questions to come into the chat. So while we wait for that, my question for you two is, when it comes to this whole situation on piping and corrosion, what do you hope is the biggest takeaway? What's the, if anything, if we have a lot of folks here that are kind of aware but not fully involved in the process, what is the one thing that you feel that people really need to know? Like, you gotta know this. What is the big number one takeaway conversation that needs to happen in this case?
I would say that my big takeaway is to make sure that you're performing your inspections at your plant. So it's the easiest way to maintain the safety of your systems and the long-term operation of your plant and the safety for those involved. I'm sure if you are working in a current steam plant, you know, one of the first things I was told when I started my job is like, you know, steam can be dangerous. You know, you could walk around with a broom in front of you and the steam hits that broom, it's going to cut it. I've never seen somebody walking around with a broom in front of them in a plant, but it is a very dangerous mode of creating power if there is a leak. It is extremely dangerous. You know, it's not, you can't see it. You can't see the steam leaking across the plant. And so anything we can do to maintain that safe barrier of the piping and make sure that we're keeping the plant safe, that's the most critical thing. So knowing that, and then you can reach out to us or other people to help you know where, you know, if you haven't done inspections before, we can help you do that. Another thing for flow accelerated corrosion was part of the reason that we decided to do this presentation today is we had a client reach out to us, and they've recently been required to perform a FAC monitoring plan for their insurance company. So it's becoming more prevalent in the companies that it is, you know, it's not a code requirement, it's a recommendation, but as the insurance companies are trying to make sure the plants are maintaining their safety, that they're requiring some of their clients to develop a plan or where you're going to look at flow accelerated corrosion.
Okay. Thank you, Kristi. And Kenya, similar with your experience and what you've seen, what do you hope is like a takeaway or solution that is easily implemented? What do you encourage people to do? What do you hope that everybody just do this one thing? What would be the best?
Yeah, no, I would piggyback on what Christy said, and just add to it that operating companies would maintain their procedures, stick to them, and also as they get their inspections done, to keep the documentation so that
Hmm.
follow up can be done and you can accurately monitor areas of concern. Um, we have some clients that are really good at that, and it helps a lot. So
Great. So say one of our clients, another client does contact us about this sort of thing. How do what's like a quick maybe summary of what could they expect of the process? So like they call us, like you just show up and you're like, oh, these are bad pipes, or how do you get into the place where, like what would they need to do? What would they expect when hiring someone like yourself to do an inspection?
I can start it, Kristen. You can piggyback if I miss something. But basically, we would need to see any documentation you have from previous inspections. If you have an existing pipe stress analysis, we want to see that. Piping isometric, pipe supports, drawings, data on operating, any history you have of areas of concern. Those are and we sort through that documentation in preparation for coming out and doing our inspections. And then we want to know the schedule. If there's an outage coming up, that's a good time to do a code inspection. Uh, and then those are kind of the sort of things that jump out right away.
And I guess to add on to that just a little bit, I would say like one thing Kenya mentioned earlier in the presentation was one of the things we look at is the hot and cold settings of the spring cans. And the reason that we do that is the location of the spring can, hot to cold, inspection to inspection, allows us to see if your system is migrating. So if you have a pipe support, maybe it's a constant or a variable spring can up near the boiler connection, and year after year, the the connection point, the reading is going higher and higher, lets us know that for some reason that system is lifting up. And we would typically need to go back and look to see if there's other pipe supports in the system that are not essentially carrying their load. That
Mhm.
sounds funny, but it's actually what it's happening. So there might be something else that's not carrying its load. I'm sure that the spring cans around the picture that Kenya showed that was not connected to the piping, the spring cans on each side of that would have readings that would have been different than when the system was originally installed. So having that history allows us to check for migration. If you were having a system that for some reason was having condensation in it, in a steam system where maybe you had a spray valve that was leaking and you're getting condensation in it, it will make that spring can sag. And sometimes indicators like that help us improve the system overall, help prevent water hammer. That can be a very catastrophic type event.
Hmm.
Um, but looking at spring cans and locations helps us see that. We can look for, maybe there's a guide that's, some kind of slide guide that's hung up. Maybe it's locked up into position and it's not allowing the system to move the way it should, and you're putting more load on your turbine.
Mhm.
That might cause turbine blade wear. It's a lot of stuff that these inspections can really help you, like we said, really extend the overall life of your plant much more than the piping. It can help your turbine, it can
Mhm.
help your boiler, it can help the whole system.
Okay. And so you do an inspection. We'll do the final question here. You do your inspection. You get everything. You get your notes. Got everything is happening, and then you get the results. And then what's kind of the process, that the next step? What would need to happen um, in order for them to kind of fulfill getting these things checked and repaired?
Yeah, so from there we would create a report that details all of our findings and any recommended repairs or replacements that is required for safe operation of the plant.
All right.
And I guess
Great question.
one final thing to leave people with that is very early in my career. So you're talking 30 plus years ago. I was hired by a large power plant to come out and do hangar inspections. We found several spring cans that didn't seem to be operating correctly, and they actually paid to have them taken down, load tested, and then put back into position and then replaced as necessary. The cost to do that is extraordinarily high. The whole contraption you need to build to load test something is extremely high. And at this point in my career, my recommendation would be to clients that you do not pay for that load testing, that if you have a hangar that is not performing and not taking the load the way you expect it to, it's giving you inconsistent readings, would be just to replace it. It would be significantly cheaper at this time than it would be to test it. 80% of them that I tested got replaced anyways. So just so something for owners to know that replacement is probably by far cheaper than testing prior to replacing if you have problems with your spin cans.
Well, thank you very much for that very, very nice, concise breakdown of such a huge thing. Let's be honest. There's a lot of pipes out there, so this is like really important. Especially just having like an inspection can a lot of issues going forward, and the fact that Kristi specifically are on task with helping kind of shape these procedures and processes going forward. It's really great to have you, and really thankful for both of you and your experience and your time and chatting with us today. So thank you for that. To wrap things up, this webinar will be recorded. It is being recorded and will be on demand. You'll get a link to it later today when GoToWebinar sends you that email with all the good stuff in it. So look for that. If you do need a link and you haven't received it, you can always reach out to me to make sure that gets to yourself, or if there's someone who wasn't able to come, you'd like to share it with them, they are always welcome to read that, or the handout, which is available for download here in the tool on your GoToWebinar tool. Keep an eye out for our 2024 webinar events. That schedule will be coming out here in probably the next few weeks, as we are preparing for 2024. Another great webinar on the way for sure. And then make sure you check us out on LinkedIn. We are sharing things related to this topic. We are sharing the updates to our webinars and other great thought leadership or just other information that you might find valuable to the company. And as a reminder, you can contact us whenever you like through our website or through my email or cai-info@cai-engr.com. If you have questions or comments about a proposal or to discuss a project with one of our wonderful experts. So yeah, that is it for today. Thank you all for joining us. I hope that you have a wonderful Wednesday or whenever it is that you're watching this, and we will see you next time. All right. Thank you very much.
Thank you.